Normal distribution is the go-to distribution for any statistical analysis. We call this as a go-to distribution because most of the distributions by default reduce to a normal distribution. And whenever we begin with any analysis, by default we assume that the distribution of the sample is normal. So, and this is also called as a Gaussian distribution in a much more general framework. But for amateur or beginners of statistics, we can address this as a normal distribution. And as I mentioned earlier, most of the phenomena in this universe are assumed to be normally distributed. Very rare few phenomena are considered non-normal, but most of them are normally distributed. The reason why normal distribution is very important because of the central limit theorem. The central limit theorem states that any standardized variable tends to be normally distributed as n tends to infinity. That means if we keep on increasing the sample size, most of the distributions, the standardized forms especially, tend to become normally distributed. Now here normal distribution is indexed by two parameters. One of them is mu, which is also the location parameter or the mean of the distribution. The other is variance, which is your sigma square, and this is the scale or shape parameter of the distribution. Now we should be very careful to interpret sigma square. If we talk about standard deviation, which is given in most of the studies, it is sigma. The square of sigma is sigma square. So standard deviation is sigma and the variance is sigma square. In short, we denote that the random variable x follows normal with mean mu and variance sigma square. So there are two parameters of this distribution. If we remember earlier distributions, for a Bernoulli distribution there was only one parameter, which was the probability of success. For a binomial distribution there were two parameters, which was the number of trials and the probability of success in each trial. For a Poisson distribution there was only one parameter, which was lambda. For an exponential distribution there was one parameter, which was lambda, and here for a normal distribution we have two parameters, that is mu and sigma square. Okay. Now let's see how we can use the functions. As we mentioned earlier in the initial part of this lecture series, the four functions are d dash dash, p dash dash, q dash dash, r dash dash, where here dash dash refers to the corresponding distribution. So here dash dash is norm, which depicts the normal distribution. Let's consider an example. Now we here in Delhi we have been experiencing for the past many years that the mean temperatures in August and September are somewhat lower than that of May, June and July. So let's say from my experience I have recorded the mean temperatures to be, let's say, 36 degrees plus minus 2.14. So whenever such a representation is given, we should remember that the mean temperature is 36 degrees and whatsoever comes after plus or minus is the standard deviation. It is not the variance. Remember, it is the standard deviation of the distribution. So let's frame the question like we wish to simulate the daily temperatures for September 2020. Here we are in August, so we wish to simulate what would be the daily temperatures in September 2020. So I have R norm, which is for generating random numbers from a normal distribution. I wish to generate 30 random numbers because September has 30 days. The mean of the distribution was 36 and the standard deviation, remember I write the standard deviation here and not the variance. So standard deviation was 2.14. The question said that the mean temperatures were 36 plus or minus 2.14. So the mean is 36. The standard deviation is 2.14. So there you go. These are the daily temperatures, simulated sequence of daily temperatures for the month of September on the basis of the previous records, which say that the mean temperatures are 36 plus minus 2.14. If we want this to be a little more understandable. So I will round these off to 2 decimal places. So there we go. So these are the temperatures. Now supposing I wish to find out the probability that temperature would be 38 on any given day. Temperature would be 38 on any given day. So I could simply use d norm. The temperature would be 38 on any given day. The mean temperature is 36 and the standard deviation is 2.14. So the chances that the temperature would be 38 on any given day is just 12%. Right? According to the distribution of normal, that mean is 36 and variance to standard deviation 2.14. The chance that we will experience a 38 degrees Celsius temperature on any given day is just 12.04%. Now, what is the probability that temperature will be less than 38 degrees on any given day? So I will simply use P norm, which gives the probability that random variable is less than or equal to any number, so that any number is 38 here. The mean of the distribution is this, the standard deviation of the distribution is this. So there is an 82.499% chance that the mean temperature on any given day is less than or equal to 38. So if you wish to find out the chance that the temperature is greater than 38, so it is just 17.5%. Supposing that 73% of days in September, 73% of days in September show a temperature of at most X. So I wish to know what this X is. That means maximum 73% of the days shows a temperature less than or equal to X. So what would be this X? So I would simply use the function Q norm and 38, 36, 2.14. So here, sorry, it's not 38, 73%, so 0.73. So there you go. The temperature is to 37.31. So probability X less than or equal to 37.31 is 0.73, which is 73%. That means 73% of days in September record a temperature of 37.31 or lesser. So that's the normal distribution for you. All the previously mentioned distributions are not the only ones which are available in R. There are many other distributions, and statistics is not only confined to these few distributions, but they have been spoken about because they were the more popular of all the distributions. The users, the students in the audience is expected and urged to look out for more such functions. R is a beautiful language, and the best part with R is it is first of all an open source language, and second thing is that you get lots of help in the R commands etc. from the internet. Whenever you are in a fix, whenever you don't know what command to use for which purpose, you can simply type a command, you can simply type a request in Google and just say in R at the end, so that you will have plethora of replies, plethora of answers to help you guide through different programming or different commands in R. So as I said initially, that you need not be confined to the commands or the distributions that were mentioned in the previous lectures. Let's say for example, if you wish to generate random numbers from a beta distribution, so you could simply use R beta. Let's say I wish to generate 10 random numbers from a beta distribution with parameter 1.23 and 1.05 for example. So there you go, we have beta distribution. Similarly, I can use the same set of commands. I can use Q beta, P beta, D beta, etc. for respective purposes. Same way, if I wish to generate random numbers from a gamma distribution, let's say 5 random numbers from a gamma distribution with shape and scale parameters, let's say 0.36 and let's say 0.21. So those are your 5 random numbers from a gamma distribution. Similarly, I could use P-dist, etc., etc. Let's say I wish to find out D. So the PDF of the gamma distribution with 0.36 and 0.21 as the parameters. For any value 5 is 0.028. Similarly, you can try out many other functions and many other distributions. R offers a comprehensive and exhaustive list of commands for each and every statistical purposes. So it's hard to remember all of them, but thankfully Google and the help that people provide, the quorum that the our programmers have is very helpful. Whenever you have problems, just type it in Google or ask a question. You will see that there will be many responses to your question, and there are many ways in which your question could be answered. So your choice is to simply choose the one which is the easiest. Thank you for all your interest. Thank you for patience hearing. Good luck with random numbers and other statistical functions and programming in